Good morning, Richmond. Hi, I'm Bill Hicks with AirRight Heating and Air, servicing your brand of heating and air conditioning equipment throughout the Richmond metropolitan area. Today we will be replacing a unit for Mrs. Kilduff of Enroth and Kilduff, who has graciously gave us permission in using their name, their house, and their time. Today we're going to be changing out this Train heating and air conditioning system. The first part of the process was my sales consultant came out to the house, measured the house, and did a complete load calculation to determine the proper size of the unit, which is required by our new mandate and government regulations. As he completed the load calculation, he determined the furnace needed to be 100,000 BTUs and the AC system needed to be 3 tons of coolant. The next step in the process was to get me to come out to design the job. We do not put a job in without the proper design for my installers to follow. Most companies come out, give a quote, and they just send the install crew out to replace it. Based on Train installation guidelines, you are not to tie ductwork into the side of the furnace unless you have the proper plenum. The proper plenum would be a square box that came out 16 inches out to where you can have the proper amount of airflow coming through this blower unit. They did it the same way on both sides. This customer has never really had a comfortable house. One of her complaints were the rooms on that side of the house never got enough air, the rooms on the far side of the house never got enough air. So as I looked at the unit, I was like, wow, what a mess. We have a humidifier installed in the attic where it's created mold and has leaked down the side of the coil. She's lucky she has not lost a ceiling. We will be removing that and disposing it. It's not the code, it has to come out. When this job is complete, she is going to have a state-of-the-art installation, and we are still able to use the ductwork that's there with some major alterations. And as you see the completed job, you will say, yes, that's something that the customer got what they paid for. And at the end of the job, 3 days later, my quality insurance inspector is going to do what they call a commissioning report. That determines that the system has been installed to the Train specifications and also the peace of mind to the customer. And it'll be another well done job by AirRight. Hello Richmond, we're back again at the Kilduffs, taking a look at the progress of the job. As you can see, we've laid the furnace down, installed a radius return plenum and a radius T plenum on the supply to maintain positive pressure throughout the duct system and to gain the most efficient system for their home, reusing the same duct system. Everything that we have put together from the furnace to the existing ductwork has been sealed with approved mastic and wrapped with the R8 bubble wrap. We feel that using a fiberglass type insulation is hazardous to my employees and also not a good source of insulation for the future. This guy is my comfort specialist, the man that actually sold the job to the Kilduffs. He is out here helping and making sure the job gets installed the way he sold it. Ron?
Well, what we have here is we have fiberglass insulation that was wrapped around the existing duct system. Once we removed it, the duct system was put together with a slide and drive type of metal work. It was not sealed, so when the air is passing through the duct, it is actually pulling in particles of fiberglass and also showing you where the dirt is entering into the duct stream. So we actually stripped that off. We redesigned the way the airflow comes out, and what that does is gives you better airflow, better static pressures in your airstream, and we are actually sealing the ductwork from the inside so we will not have any more air leaks in the system. What we use is an R8 type of bubble. There is no fiberglass in it, and it helps create an airtight, healthier environment for the family, healthier environment for our employees as well. Okay, what we've done with the outdoor unit is when we install an outdoor unit, we want to raise the unit off of the ground level. As you can see, this one here has tilted back. It wasn't level. It's not raised off of its actual pad. So we'll actually build a foundation, treated foundation, condenser pad. Then we're going to actually put a set of feet under the unit to raise the unit off of the pad. So if it does rain or water, or when it goes into when water starts to drain, it can drain out of the bottom of it, and also it gives a better airflow all the way through the unit. So what we're trying to do with this is to raise it off of the ground, keep snow from piling up around it, leaves, and just it gives it a much better appearance as well. So that's what we're trying to achieve with the outdoor unit. This particular unit does have a top on it, so it minimizes snow and ice and rain from falling down and around the compressor. The units are much taller now from several years ago, and the bigger and taller the coil, the more efficient the unit will be. And so that's how we install our outdoor units. Alright, Richmond, this is the final product for our installation with the furnace AC system. What we did is, on the return side, we did a complete radius turn to bring the air back through the system so it can be reheated or reconditioned and humidity removed in the summertime. We had two returns that we were dealing with to tie in, so we've got one tied in the top and one tied into the side over here. As the air flows through, it is going to come into what's called a radius T-fitting. We're going to turn that air, and then we're going to transition it down, which you'll see right here on this side. The air is going to carry down into this drop and then into the duct system. So on each side of the ducts, I have the ability to adjust the air from one side of the ductwork to the other. And what that will do is that will allow the air to flow through the duct system freely without pressure back on the unit. The starting point of this job, before we even took out the old system, was to do what's called a heat load calculation, where we will actually come in ahead of time, draw out the floor plan of the house, measure each individual room, the windows, the compass direction of the house, the insulation factors of the house, the insulation factors of the window, and we're going to come up with airflow per room, which is going to allow us to properly design this system so we know where to put that air. And this is our final product. It's up and running. That's about as loud as it will get. You have a draft where it's going to pull the air in so it will burn clean, and it will exhaust the fumes out through the roof. And that is our final product.